Assalamualaikum and very good day everyone. I am Dr. Nur Suhailiza Sazali from Polytechnic Jeli Kelantan. Today I would like to present my research with the title The Comparison of Additional Zeolite and Perlite as well amendment on the growth of KAILAN. Before we go further, I would like to explain about the table of content for the presentation today. The first one, I will start with the introduction. For the introduction, I will divide it into 4 subtopics. The first one about the background study, problem statement, objective, and also the scope of my study. The second one about the methodology of my research. The third one followed by the result and discussion. And the last part is a conclusion. So the first one, I will explain about my background study. So about the background study, I'm focused on the agriculture because we know that agriculture is very important sector, not only in Malaysia but all around the world. This agriculture sector contribute more than 20% of Malaysia gross domestic product GDP, making it one of the country most important sector. Malaysia agriculture product have seen increase in demand from domestic and also international market in recent year, leading to the increase of export earning. So for my research under agriculture, I focus on the growing of the KAILAN by using the this material. I will explain later. And then in my research, I've done my research in greenhouse. Why greenhouse? Because I want to control the environment and also the irrigation system. So next about the NPK fertilizer, we know that all the plantation need the NPK as a source of nutrient for the plant. But unfortunately, the excessive use of NPK, uncontrolled use of NPK make the leaching problem in agriculture, leaching of the nitrate and also ammonia from the NPK. So for this research, I would like to reduce or eliminate the leaching problem of nitrate by introducing these two materials, which are perlite and also zeolite. What is perlite actually? Perlite is a hydrophilic rock that has a relatively high water content, and therefore its particle can absorb more than 400% of water than their own weight. During the irrigation, the granules give moisture to the root that make it this perlite improve the quality of the soil. So for the zeolite is a microporous crystalline aluminosilicate material that commonly used as a commercial absorbent and also cation capability as a cation exchange capacity. So by using these two materials amended in soil, we want to decrease the leaching problem in agriculture, and also we want to increase the growth of vegetable KAILAN. So after we amended this material, and then we harvest the plant, which is for my research is KAILAN, to check the plant growth characteristic and also the leaching problem caused by the nitrate and nitrate. So for analysis of the plant analysis, I use one-way ANOVA by statistical analysis. Next, about the problem statement. So for this research, I have two main problems that need to be solved. The first one, like I said before, is the leaching problem of the nitrate and ammonia. So this leaching problem, we know is the losses of the water during the irrigation because of the excessive use of NPK. So we want to mix this soil with the perlite and zeolite to sustain the NPK in soil. Next, about the quantity and production of vegetable in Malaysia is still low. Why still low? Because Malaysia is still import vegetable from other country. So by using these two types of material, we want to check is it can control the leaching and also can increase the growth of plant. Next is about the objective. So we have two main objectives. The first one, we want to compare the effect of this additional zeolite and perlite mixed with soil on the growth of KAILAN, and the second one, we want to distinguish the effect of the zeolite and perlite on minimizing the nitrate and ammonia losses. So for the scope of my study, I have two main scopes. The first one about the plant growth characteristic. For the plant growth, I focus on the plant height, width of leaf, number of leaf, and so on. And then for leaching test, we want to check the concentration of the leaching of nitrate and ammonia after amended this material in the soil. Next, about the methodology. So for the methodology there, I have two main parts. The first one about the material itself, and then the second one about the applications of this material towards the as a soil amendment. So for the material, for the zeolite, I synthesize by myself the zeolite by using the hydrothermal synthesis from the kaolin. So from the kaolin, we need to transform into the metakaolin by the calcination process, and then for the metakaolin, transform into the zeolite by conventional hydrothermal synthesis with a specific parameter. But for the perlite, I just buy the perlite from one of the factory manufactured in Malaysia. And for the application of these two materials, we apply these two materials to check the plant growth analysis and also to check the leaching analysis. And I analyze by using the statistical analysis one-way ANOVA. And then about the greenhouse experiment. So in greenhouse experiment, first we start with the number of treatment first. So for this research, I have 4 different number of treatment. The first one, soil with standard NPK. Next, soil with low added NPK. The third one, soil with standard NPK added with 5 gram of zeolite. And another treatment is standard NPK with 5 gram of zeolite. So quantity of zeolite for the standard and for zeolite and perlite is 5 gram of NPK, and for the low NPK, the quantity of fertilizer is only 1 gram. So for the greenhouse, the design, the arrangement of pot in greenhouse is randomized. So we have 4 treatment, and then we do repetition of each treatment 10 times and harvest for 2 times. So we can see the image of greenhouse for my experiment, and also this freshwater master kit I used to check the concentration of nitrate, and ammonia by using the comparison of color. Next, about the result and discussion. So the first result must be on the material. So the first about the zeolite. So zeolite I analyze with the XRD analysis and the PSAM analysis. So for the XRD analysis, we can see the peak for the XRD analysis LTA. For the green one, you can see that there are 10 peaks that indicate the zeolite LTA. So we successfully synthesis the zeolite LTA from the kaolin, metakaolin, and into the zeolite. So by using this specific parameter of synthesis of zeolite, we can have the high percentage of crystallinity of zeolite with more than 86%. So for the PSAM image here, for the A, we have hexagonal plate shape of kaolinate, and for the B, we have a very highly disordered metakaolin. And then the C1, if it is a zeolite family, the structure is a cubic morphology crystal, and the average diameter of zeolite is the 43.8 nanometer, and this zeolite composed with the chemical composition of silica and alumina and also sodium oxide. But for the perlite, then we have the range dimension of the size of the perlite is about 0.15 mm to the 2.5 mm, and then the chemical composition is also composed with the silica, alumina, and other chemical compositions. Next, about the plant growth characteristics. So for the plant growth characteristic, like I said before, we have to harvest. So for harvest one, we start with the plant height. So the plant height, by using the statistical analysis comparing the one with ANOVA. So we have here mean have been given different letter above the column. They are significant different at P less than or equal to 0.05. So for the plant height, 5 gram of zeolite show the high significant different compared to the standard NPK and also low NPK. But for the width of leaf for harvest one, there is no significant difference. So we move to the weight of the shoot. We see that 5 gram of zeolite show the height significant difference with the low NPK, and for the dry shoot weight, 5 gram of zeolite show the height significant difference for all the treatment. And for diameter of stem, we can see there is no significant difference for all the treatment. And number of leaf, we can see that low NPK show lower significant difference towards other treatment. And all the pH for all the treatment at the range 6 to 7. So for the plant growth analysis, beside comparing the mean, so by comparing only the mean without the statistical analysis, we can see here with 5 gram of zeolite show the high plant growth characteristic compared to the perlite and other treatment. Next, the same goes to the plant growth characteristic at harvest 2. At the plant height, 5 gram of zeolite show the height significant different compared to the standard NPK and low NPK. And unfortunately, for the width of a leaf, there is no significant difference for all treatment. And for the rest of the treatment, 5 gram zeolite show the height significant different compared to other treatment. Next, we move to the leaching analysis. Like I said before, we analyze with the nitrate, and ammonia. So for nitrate here, there is no significant difference for all treatment, but for the nitrate, we can see 5 grams of zeolite show the lowest significant difference compared to the standard NPK and perlite and ammonia also. Zeolite show lower significant difference toward low NPK. So for the mean concentration of nitrate and ammonia, we can see 5 grams zeolite show the lower concentrations of nitrate and ammonia leaching compared to other treatment. So the last but not the least about the conclusion there. So according to the result and finding in plant growth analysis and also leaching analysis, we can say that zeolite was the best soil amendment to increase not only for growth but reducing the leaching of nitrate and ammonia compared to the perlite. So that's all. Thank you very much.